All right, welcome back. We're now looking at the cubed root parent function. So a cubed root is just, cube means the third. So either to the third power or the third root. So on this one, my cubed root parent function is just f of x is equal to the third root. You're going to make that 3 the index, the third root of x right there. Now, this is a little trickier for people to graph. Again, I'm going to go ahead and do my XY table right here. Now, remember, when we squared our numbers, this was kind of easy to see. 1 squared is 1. That just means 1 times 1 is 1. Anything times itself. So you multiply it by itself 2 times. 2 times 2 is 4. 3 times 3 is 9. So the square roots just worked backwards here. Same thing with the cubed roots. It's kind of easier to work backwards. So, if you want to go ahead and do that, let's start with 0 again. 0 times 0 times 0 is 0. So this time we're just multiplying by itself 3 times. The nice one is 1 times 1 times 1 is still 1. So these 2 points are the same points in that last function. However, this one changes a little bit. 2 times 2 times 2, so 2 times 2 is 4 times another 2 is 8. Okay, so this means when my x value is 8, when I go over 8, 1, 2, 3, 4, 5, 6, 7, 8, I go up 2. That's going to be my point right there. All right, the next one's going to be way too big. 3 times 3 times 3 is 27. I'm not going to graph that. So I'm just going to kind of connect those dots, and I hope you could see, though, that it is going to go up as we go. So it's going sideways, but it's barely going up as well. Okay, now this one's a little different because you can actually take the cube root of a negative number. Before you couldn't. If you, there was no way, like 1 squared is 1, but if you square negative 1 times negative 1 is also a positive 1. So you couldn't do a negative number, but down here you can. If you plug in negative 1, well, negative 1 times negative 1 is positive 1, but when you times it by negative 1 again to cube it, it gives you a negative 1. So that means when my x is negative 1, my y is negative 1. And these are all just going to be negative numbers. So I can also square negative 2, and it will give me a negative 8, which means when my x is negative 8, my y is negative 2 right here. So this picture actually keeps going both ways. Okay, so that's a nice, pretty picture of this. So your domain on this one is easy. Okay, cube root, parent function, any cube root function, if it has a cube in it right here, your domain, you can memorize again, is negative infinity to positive infinity. And so is your range. Isn't that nice? Your y goes forever too. It's going to take a long time to get there, but it is slowly going down, slowly going up over here. All right, so on this one, there's no endpoint. We're going to cross that one off. That was for our square root, but there is what we call a turning point. You'll notice right here as we're following along on this graph, the turning point kind of came from, see how it's kind of sloping up right here, and then it kind of turns and starts sloping down. So this origin right there, my 0, 0, just for the parent function, this will move again as we start shifting it to the left and right and up and down. That'll move. For this one though, the turning point is 0, 0. So it looks like it slopes up quick right before that turning point, and then it slopes up quick and starts evening out after that turning point. All right, so these end behaviors, again, they're still just your domain. So you can write those in. They are the same ones that we've been doing before, negative infinity to positive infinity. Now, you do have to check on this one for your y's. Before, when we were doing them, they were basically like our absolute value functions and our parabolas. They both went up on both ends. Notice this arrow is going down slowly, but it's going down. This arrow over here, slowly, but it is going up. So our end behaviors are different on the left and the right of our function. So just remember, this is their fancy way of saying the left side. As x approaches negative infinity, that's the left right here. So on the left, my y is going down. It's going to negative infinity. Okay, as x approaches positive infinity, or that's the fancy way of saying the right, my right end right here, this arrow is slowly going up to positive infinity. So that is your end behavior. And then just like our square root up here, you're only going to have one of these intervals. It's either going to be increasing or decreasing. It doesn't do both. So when you follow this along, look, we're reading left to right. As we follow along, are we increasing or decreasing? Well, we're slowly increasing, then quickly increasing, then slowly increasing right here. So we're always increasing. So go ahead and cross off that decreasing. And again, it will just always be your domain. We're always increasing. So it just goes forever from negative infinity to positive infinity is where we're increasing. And that's how you graph a cube root.